there. This is our first attempt at a podcast. This is something we're calling Never Rewrite. This podcast will be explained in a moment by my co-host, Jeffrey Sherman. Jeffrey, are you there?
Hello, this is Jeffrey Sherman. Good to be here. I'm excited to talk about, never rewriting. It's sort of a philosophy of ours. It's not that you never rewrite your code. It's that you never start over and try to rewrite your whole thing from scratch.
Got it. So tell us, before we get into the podcast, tell us, who are you? What do you do?
So I'm a software developer for, over 20 years. I've been actively developing software for, I've been getting paid to develop software for over 25 years. But as a full-time professional for like over 20 years. And these days, I help SaaS companies scale their platform when they finally got that product market fit and they're scaling, and some of those early decisions they made that didn't matter because you needed to get something out the door. Right. Now they're coming back to bite you because, hey, you can't handle hundreds of thousands of customers. It's a good problem to have.
Yeah, it's a great problem. I'll introduce myself here. I'm Isaac Askew. I am not as experienced as Jeffrey. I am catching up to him. He keeps getting further away every time I try to catch up, though. I have about 10 years in the software development industry. I'm also paid to write software professionally. So I feel like it's almost like a meme at this point whenever a developer comes in and they say something like, oh, this is awful code. I think we should either just trash it, or even better, we should rebuild it in my favorite language that I just discovered a couple of years ago that I'm obsessed with. You can almost see like the 0 days since last JavaScript framework kind of new JavaScript framework kind of joke, because the new one comes out, someone gets obsessed over it, they want to build in that thing that they know, and your awful old code base is the perfect excuse for rewriting.
Yeah, the warning sign there is if anybody ever comes to you and says, look, this code is so bad, we just need to start over. It would be easier to start over. Our code is so bad. And never answering the question of, who wrote the code? And if you made it so bad this time, what's going to be different for next time?
Yeah, there's like a, it's like a kind of a recurring loop. I think the pattern that we see is like, there's a startup, they need something delivered quickly. You deliver it as quickly as you can, and you do it poorly because you don't add tests, you don't think about the future, you're just trying to deliver for that one customer or somebody who gives you money, right?
It could even be more innocent than that. Like you could write all the tests, probably not all the tests, but it's a startup, they think they're going to do one thing, and halfway through they realize that they need to pivot slightly, and soon the original design it's just not right anymore.
Right.
Whether you built it right, whether it was well built or not to begin with, it's the company started off, selling books online, and now it's a selling everything online store, the Amazon story, right? That it's not exactly the same thing it was.
By the way, the loop that I think occurs is once you end up building that product and you've built it hurriedly, then the other developers come in, they're fresh to it, and they go, oh, wow, I see what you did wrong here. I wouldn't have done it that way. But they would have if they were rushed as well. But they think from fresh eyes, oh, this is awful. Who built this? Why did they build it in such a sloppy manner? I could have done this way better because hindsight's 2020.
In 6 months.
In 6 months. Yeah. I could put it super quickly. This will be super easy. There's only a couple of features here. This is a basic platform. And that's the concept. And so you could actually almost see it playing out if someone said yes to them and they rebuilt it. And then a couple of months or years down the line, someone else comes in, who built this? This is awful. I can rebuild this really easy in 6 months. There's this tangled dependencies. And the loop, just the cycle continues from each set of fresh eyes every few years, because each person will just end up building their own brand new monolith in their new flavor of JavaScript or whatever code they cared about.
Well, that's if you're lucky that happens. If you're less likely, the more common thing is, oh, I'm going to start over 6 months down the road. They're like, oh, I'm getting pretty close. But meanwhile, the original system is continuing to be maintained. It's had new features. And so the new system is always a few months away from getting into production. And sort of the worst case there is a year or even two down the road, you cancel the new system because the old system is now, it's still the thing that you're using, and you just throw away all that work of building the new system because it never got into production. That's sort of your worst case.
And a ton of wasted money and all the time
Tons
spent trying to convince leadership that this is the right way to go, rebuilding everything. So what do you do instead if you never rewrite?
You iteratively rewrite. You one piece at a time, you change it from what it is to what it needs to be. And that's, it's a push and pull and a tug here and a push there. And you eventually, you slowly evolve it from what it was and to what it needs to be. But at no point do you ever, the big conceptual shift is at no point do you ever write code or changes that don't go into production. It may not be as theoretically fast or as theoretically efficient as, I'm just going to start over, I'm going to build a new thing, not have to worry about modifying this existing edifice. But it will end up being much faster in reality because you don't have to wait until the whole thing is done before you get any value out of it.
Is there any examples that you're thinking of? Can you help the listener understand like that process besides conceptually, just kind of like a literal project that you worked on to solve this?
Well, I've come across an amazing example, real world example that I think everyone can get their heads around that I want to go with. So in the software world, the idea of, hey, what we have is terrible, and we're going to do called a greenfield rewrite, and then we're going to do what is called a big bang cutover, where one day we're using this system, and then the next day we're going to use the new system, and we'll then turn off the old system. It almost never works, but I found a real world example of somebody doing it in the real world that I think is very illuminating.
Sure.
So the Yankees baseball team has been playing in the Bronx for many, many decades. And they had a baseball stadium and they didn't like it. It wasn't big enough. It didn't have enough seats. The seats were terrible. And so in the 80s, they started saying, hey, we need to build a new stadium. And for 30 years, they basically said, hey, we need to build a new stadium. We need to build a new stadium. So they didn't particularly do any iterative maintenance. Like they maintained the stadium, but they didn't evolve it. And eventually, after 30 years, they got permission. They built a new stadium across the street from the old stadium. They took over a park. They built a new stadium on it. They moved the team over. They knocked the old stadium down. They built a new park, right? So it's as pure of a, look, we're going to take a green field, build a new stadium on it, literally. And then one season we play here, the next season we play there, and then we destroy the old system and we put a new green field there. So it's as pure of a real world physical example as you can get. And after planning this thing for 25 years, they built a stadium. And well, first of all, that was incredible that they actually managed to do it, but the stadium was not good. The outfield wall was built wrong, which caused it to become a home run derby. They angled the stadium incorrectly relative to the wind in the area, which caused it to become a home run derby. They spent a lot of money building this whole hospitality idea, which is a big moneymaker, which is great, I guess. Totally fine. But the hospitality suites right behind home plate were so expensive that even during playoff games, those seats, a lot of them were empty. So on TV, the stadium looked empty because there was nobody sitting there. These ridiculously expensive seats. And in order to build these ridiculously expensive seats, it ended up building a moat to keep the plebeians, I guess, away from the expensive seats, which made it impossible for fans who aren't rich to come down towards batting practice and try and get autographs from the players. So beyond building a terrible stadium, they also broke this interaction between the fans and the players, which is, fans are what your entire idea is built on.
Right. Yeah.
Baseball has no inherent value beyond the value that people enjoy and have the whole experience. And so the things they got were the hospitality suites and slightly bigger general seats. Every seat got a cup holder. Like, that was important enough that it made it on the Wikipedia page. And that's kind of what I'm going off here. Like, that's how minuscule value adds were, that they spent 30 years planning to build a stadium, built a stadium that was actually not very good for baseball. But hey, they got cup holders at every seat. And that's kind of your best case. That is a phenomenal success for a Big Bang rewrite. You will not get better than that. Then, hey, you got a system that doesn't, it's not good. It's not as good as the old one, but it almost works correctly. And it does get you some of the features that you've been wanting.
Right.
When I came up with that example, somebody said, hey, even better, Madison Square Garden, which is also in New York, it's now the oldest stadium in New York, has been continuously upgraded and iterated on over the past 60 years. So it started off, it had 4 tiers of seating, and then they decided, oh, well, that's no good. So they merged levels 1 and 2 into a larger bowl. So they were able to increase the number of seats, reduce the number of, increase the exits, improve the flow. Then they merged a decade later, they merged levels 3 and 4, and they raised the floor, right? So not only did they rip out some things, they merged it. So they went from 4 levels to 2. They moved the floors. That let them add hospitality suites, which was the big thing that the Yankees wanted.
Right.
They've changed out the restaurant and eating options. They've added flyover walkways to give people new and interesting ways to look at the action. And they've been didn't make it to the Wikipedia page, but I bet at this point every seat at Madison Square Garden has a cup holder. And so Madison Square Garden, they've been iteratively updating it, and now it's like everybody loves it. When it was first built, people hated it. They were like, "Oh, this is it's cold, it's terrible." And now everyone's like, "Oh, it's a great seat." It's been worked in. And people do want to tear Madison Square Garden down and build a new one a few blocks away, but it's not because they think that they can build a better Madison Square Garden. It's because they want to build something else on the land that's on Madison Square Garden. They want to build a better train station. They want to build condos, all these other things. And so people are constantly talking about moving Madison Square Garden, but it's not because they want a better Madison Square Garden. It's because they want the land underneath it.
So 2 examples of a bad case where someone's rewritten essentially and didn't provide much value from it, wasted a lot of time and money. And another real world example where there was more iteration. It led to a better experience.
Right. Yeah. Madison Square Garden has gotten better over the decades, and people love it. Fans love it. Whereas the new Yankee Stadium, it was kind of a pit because they didn't change anything. And that was kind of on purpose, so they could be allowed to build a new one. And then they finally built a new one, and it wasn't a very good fit for their actual use case because they took one shot in the dark and didn't quite hit the mark. Even though they had 30 years to take.
Back to the software examples, what do you think goes through the minds of the people who make the decisions that we're going to agree with the engineers and say we're going to rewrite this? You think it's just an ignorance to it, or you think it's just politics around building a brand new thing and they just want to look good to the team? Why do people want to do this? What's the instinct?
I think the managerial instinct is that this is a bad idea, but they don't know what the other options are, right? There aren't a lot of people out there like you and I who are saying, hey, never rewrite. There are tactics, there are strategies that you can apply to what you have. That there's never a case. No, I don't want to say never. There's almost never a case where what you have is so bad that you would be better off starting over.
Right.
Almost. Even if what you have is so bad that it's costing you money, you're going to need to figure out the process of figuring out what you do have so that you can make a new one gives you the opportunity to fix what you have. And so by the time you understand what you have well enough to build a new one, you're going to have fixed it.
Right.
And I think a lot of it is accepting the premise of, oh, this is so bad we can't fix it, or we wouldn't even know where to begin,
Yeah.
or that you could build a new one without being able to answer that other question. But I don't think there's enough examples, and that's what I'm hoping you and I can bring to the table here, or bring to the world. So we grandiose vision of ourselves. We're going to bring this alternative idea to the table of, look, what, if developers come to you and say, oh, this is so bad we can't, it has to be rewritten. We're hoping you can come talk to us and be like, we'll never rewrite. Here's how you do it.
Yeah. And I think too, from the engineering perspective, not just the decision makers, higher level people perspective, I'm just like reminded of my first time encountering somebody else's code that was very old, but still a moneymaker, right? A lot of times people hear the term, the monolith, and they think it's a negative thing. But monoliths can be design choices. It can be more affordable sometimes to create a monolith rather than break things apart. So when I first, yeah, when I first approached it, I was like the same. I think it was just more of a naivete on my part, where as an engineer, I was thinking, especially coming from an academic background, and in the academic background, you always hit your deadline because you're turning in, every 2 weeks or whatever, you have your project, you turn into your professor, you get graded, everything is very scheduled. There's never like, oops, you missed Q3, deadline. You're always scheduled. And then you're given plenty of time, and the outline of what you turn in is perfect. This is what you code. As long as you code this perfectly and you turn it in, you will get a 100. It's very not how the real world works. So as I came and saw this code, I was thinking, who wrote this? How did this even get into production? Because this wouldn't even have passed any standards from the academic world. And then once I realized how many things get pushed aside because of like money, essentially, people demanding, customers saying, how we'll give you more money if you go this route. You have 10 customers, one of them pays you the most, so you go with their vision of what the product should be. Then you end up like coding, if customer ID is this, do one thing. If customer ID is this other person, do another thing, because you're trying to accommodate every person. You don't have that context as like a brand new engineer coming in. You don't understand how things have evolved in the truest sense of that word over time.
That's
very,
true.
very over time. Yeah.
Yeah, definitely thinking back to my college days, a class that would have been great, but is really not a collegey class, would have been understanding and working with somebody else's code.
Oh, for sure. There's, I remember I was arguing with someone about this recently. I had to take a class on databases, and in databases, it was primarily just MySQL they were talking about, or just relational databases, and they were talking about normalization of databases and how to make like the purest, most beautiful database organizationally. And they showed you how to do
Form
that.
normalization.
They showed you how to create this, and there was a whole semester's worth of material on it, but nobody ever told you that you might never encounter that in the real world, because people make the messiest stuff. There was never a how to maintain, optimize, and curate other people's messy code bases or messy databases, how to organize that kind of thing. So honestly, I feel like that example, if we had classes that were about managing imperfect code rather than trying to create perfect code, or databases for that matter, that would be much more helpful, at least in my experience.
Right. There's it was some lawyer movie, where they talk about, when you're med school, they teach you all about the theory of medicine, and then they make you be basically a doctor intern at a hospital for 3 years, a resident, to teach you actually how to apply medicine to people. And the characters were talking, it's like, oh, as a lawyer, you get all this legal theory, and then we send you out into the real world, and you have no idea how to do law, like how to actual do a case and work it. We kind of have the same thing in the software industry, and we don't even have the bar to kind of put a minimum competency standard. And I'm not advocating for it, but like, you get out of college or self-taught, and you have no idea what you're doing. 100% of the people.
Yeah, that's absolutely my case, because even I remember some of the classes I took for computer science were like compilers, how to create your own language and how to, write a compiler, assembly, which I mean, it's interesting to know, but never had to code assembly. Logic gates, binary, some stuff
Logic
like that.
gates.
And then a lot of math, calc 1, 2, and 3. And a lot of that I never used. Most of that I never used. Once I was thrown into my first startup, and they were like, "Oh, you learned C++ and Java? We don't care about that. Here's PHP,
Yeah.
it's some really bad jQuery. Learn that real quick, and you'll help us deliver." And so I learned all that, and then I found slow code, and I didn't even think about big O notation. I didn't think about what kind of algorithm this is. I just thought, "Oh, those are a bunch of nested loops. I can see what's going on here. That seems stupid." So
Right.
there's higher level ways of looking at it that I'm sure are useful maybe in other areas, but in the fast-paced startup world, I think a lot of those problems expose themselves as very obvious. Like in general, the idea for me is that coming in as an engineer and seeing this old code that seems non-performant or very difficult to change, my first instinct from that background was, this is somebody who does not know what they're doing. Instead of understanding this is somebody who made calculated decisions to deliver value because money was rolling in. And that's the first big piece is don't assume the code you're written was written by dumb people. I think that's one of the first pieces.
Yeah, that's a huge thing of having empathy and grace. And I don't know if forgiving the previous developer is the right way to say it, but just assume that the previous developer did what they did for a reason.
Right.
And the reason is not that they were stupid or that they were incompetent. If you needed to write something that's not good, but because it's going to keep a customer from walking out the door, it's great.
It's great. Yeah.
Yes, you may know that the code is not good, but it's judge us not by our code, judge us by our impact, or it's about the outcome. It's not about the code.
Right. So, and I feel like that was still another one of the biggest kind of barriers for me to overcome as like a junior engineer coming into the industry, is me understanding the code written before me was written for a reason. It was written by somebody just as smart as me that made this decision. And I guess abandoning that ego around it. Because I think ego is what drives a lot of the decisions to rewrite. You think you can do better. You think people came before did worse. And you think your solutions are better.
Yeah. Maybe we could start wrapping, because what we would love for our audience is bring us problems. What we would love to do, more than talk about how software coder should be written, we would love for you to bring us your real life examples. Like when you have some code and you're about to come to your boss and say, "Look, this is so bad, we have to start over. There's no other way forward."
Mm-hmm.
Well, reach out to us. We'll have you on, and we can help you talk through how to find those first, toe holds, finger holds into the existing system, so that we can start pulling it apart, and you can make iterative improvements and never have to rewrite it.
For sure. All right. Well, that's going to wrap us up for today. If anybody wants to submit some examples of this that we can, or maybe have like a real life lab and work through for the next episode, send it our way.
We'll have it in the show notes.
Have it in the show notes. All right. Thanks everybody for attending the first episode of Never Rewrite. I'm Isaac Askew.
Sherman.
And we'll see you next time.
See you next time.